that was generally available in 2015. So,
whoa. Nice.
I just still think of Half-Life when you say Lambda.
Different viewpoints makes us rich and successful. I think we're live.
Are we live?
Yeah, we're live.
This is exciting. I guess I should introduce myself. My name's Michael Kolwitsky. Hang on, I've got slides. I'm here to talk about managed disks. I'm more from an infrastructure side of point of view of Azure. Canio does a lot of the developer speak, as I call it.
Yes.
But my background's pretty much been infrastructure the whole way, and then into Azure.
Somehow I see now you're Azure.
Well, it's still Azure infrastructure, kind of. It's virtualized infrastructure. So software defined, that's what they call it now, don't they? Software defined everything. Let me push the button. So you guys are not seeing the right screen here. We need to change that. Right, okay. That one, and if I push that button, Canio, are we now seeing the right screen?
Yeah, there is a little bit of delay, but I think it will come eventually.
Let me know when you see the same that's up there.
We're getting very, very close. You know, I maybe think so many times.
Okay, so you're seeing the other. Okay.
Yeah.
Let's do this. And let's just stick with this. It's not perfect, but we'll roll with that.
Yep.
Okay, so who am I? Michael Kolwitsky, and that's the correct Polish pronunciation there. It's taken me a long time to convince people that's how to say my name. When I was in high school, it was Kolwicki. And when I first came to Japan, actually, I didn't quite get the katakana right, and it came out as Kuru Uwisiki. Which was for my benefit. I'm from Scotland, so I told a story about how it's a Scottish name, and it talks about the cold mountain waters that make the whiskey. And it was a good way to meet people and chat. Anyway, it's Kolwitsky, it's Polish, in case anyone hadn't realized. So from Scotland, now living here in Tokyo, and been here for quite a few years now.
Sorry.
Yeah.
Your microphone is unmuted.
It is unmuted. Otherwise, it'd be a fairly uninteresting presentation for those attending online. Okay, that's great. I'll go back to the presentation now. Right. I've been in IT since '99. Used to work for Big Blue, and that was kind of interesting. We got to play with development servers, development laptops, and test to make sure they're working. The servers would start, there'd be a handmade metal box, and they would have just a sheet of plastic for the motherboard or planar, and then blocks of wood that would represent the processors, and then we would do thermal testing, airflow and that sort of stuff. And it would all go all the way through to actually being a finished server. Laptops were not quite as old school as blocks of wood, but it was certainly an interesting place to work. So as it says up on the screen, I now primarily work with Azure and Windows Server infrastructure. Now, just going back to saying that I'm from Scotland, I know I have an accent, and I'm going to try and be as clear as possible. If there's anything that I say that you don't understand, just let me know, and I'll repeat it in my best attempt at English. I think my accent's not as strong as it used to be, so it shouldn't be too bad. Also, if there are any questions, just let me know, and I'll answer them as best I can. Okay, so as I briefly mentioned before, I want to talk a little bit about infrastructure, in particular managed disks. And managed disks are a fairly recent addition to Azure. I think it was February this year that they went live. They were in preview before that,
Yeah.
but they went effectively live in February, and now they've become the default when you're creating virtual machines. Just in case anyone's not aware, when you're building a virtual machine in Azure, you do need storage. You need to set up your storage. You need to set up your compute, and you need to set up your networking as well. So this is obviously just focused on the storage, and it's a change. It's not a breaking change, because the original way of setting up disks is still available, and I'll discuss that in a moment. So tonight I'm going to briefly discuss the old way, the new way, and then how to get from the old way to the new way. And there's a couple of different ways to do that. And I'm going to demo this. I'm going to demo managed disks in the portal. I'm going to demo converting disks with PowerShell. I'm not going to do Azure CLI or ARM templates tonight, but just so you know, you can absolutely use managed disks with both those methods. So the old way. When we were building a VM, whether it was in the portal or whether it was with PowerShell or Azure CLI or ARM templates, we would need a storage account. And in the storage account, we would store blobs. And within the blobs, we would store usually a container, which is just a fancy name for folder. And then you would have your disk, your VHD within there. And currently, and just for your information, it's still just VHD that's supported in Azure. VHDX is still not there. I don't know if Canio knows anything about the lead time for that. On that topic, there are some very useful tools, and some in PowerShell as well, for converting from VHD to VHDX and vice versa. So if you are going to use a disk from on-premises and send it up, you can do that. Pretty straightforward. But yeah, the old way: storage account, blobs, and virtual hard disks within those blobs. The storage account, when you created it, you could set it up in a couple of different ways. Here come the acronyms: RAGRS, read, access, geo-redundant storage. So that's the storage account and its contents are replicated in another region, but it's read-only. So you can access that if you need to access that data if there's a problem with the first region. GRS, geo-redundant storage, exactly the same, except you can't access a read-only copy in the other region. ZRS or ZRS, depending where you're from, zone redundant storage, that's within, they call them facilities, but let's just say data centers. So over a couple of different Azure data centers in the same region, that's where your data is replicated. And finally, local redundant storage, LRS, which is 3 copies within the same facility or data center. Now, the reason I'm telling you guys this is because when we move over to the new way, one of the main caveats is that it's only the LRS that's available. Okay, so it's very much worth knowing about if you're considering moving to managed disks. Now, there are quite a few benefits to moving to Azure to managed disks. Let me get rid of that box. There we go. So the storage accounts are managed by Azure. So it's a layer of abstraction. So you don't need to worry about any of the limitations with storage accounts. You just say, you know, I want a disk for this VM. I want it to be this size, and it's going to be attached to this VM. Go, and you know you have your disk. You don't have to worry about the storage account underneath that at all. As a result, that means it's now a top-level resource. And if you look at the screen capture on the right there, next to my VM and my NIC and my network security group, we've got a disk icon. The great thing about that is that you can now use role-based access control with that resource. You can control the access to that. Whereas previously, you'd control the access to the storage account. Okay, so a bit more control over your environment and the administration of it. I'm told that it's better performance. I haven't tested this myself, so I can't really vouch for that. So moving on. Like the original disks, or now called unmanaged disks, we have a standard tier and a premium tier. Premium is based on SSDs, standard on hard disks, spinning disks. Okay, we can move them between them. We can move managed disks between the two tiers pretty easily. Some of the other cool things, and oh, I've got a typo there. We can actually create reusable custom images now from managed disks. This means that we can take a copy of that disk and then use that to redeploy to new VMs based on that original disk. So it's a nice addition to the features that allow deployment a bit easier up in Azure. The other cool feature is independent snapshot backups. Now, if you're familiar with virtualization, a snapshot in Hyper-V tends to be a new disk that's created that stores the differences between the original disk and the snapshot that you've created. There is a dependence there. However, these independent snapshot backups are independent. You can take effectively a backup of your managed disk. And then maybe copy that to another region so you've got that safely stored elsewhere. There is a link in the bottom right-hand corner for more information on managed disks. That's one I stole off of a Microsoft website, and I've checked it is still valid, so that'll take you to the managed disk homepage. What I'd like to do is maybe just do a few demos. Yes?
Questions. Why would someone try to take a snapshot? Because it's supposed to be redundancy and everything's there.
Yes.
That is my understanding.
However, let's just say someone goes into the VM and makes a configuration change and breaks the VM or deletes data. So rather than having redundancy within the same data center where you've got 3 copies of the disk, that's not really a backup. That's just more, it's highly available to allow for either faults in the data center, faults in the rack, for example, the networking or in the storage, or updates in Azure, because Azure needs to update its hardware. So in the locally redundant storage will give you redundancy within the data center, but it doesn't protect from changes made to the disk itself. Let's say, for example, someone goes in and formats a disk. Maybe there's a data disk attached to a VM and formats it. The data's lost. But there's 3 copies of that lost data, and empty data.
So you said that's protection against customers' mistake than the infrastructure.
That's right, yeah. So it's more of a, you can use it as more of a backup solution rather than a redundancy solution. Yes, I'm sure there'll be other scenarios that you could use it for, but yeah, good question. So
then you mentioned about premium,
yes.
SSD version. Do you have a code doing that? Like, things that I rarely touch, but I still want it to be around, but I want to check.
That's a good question, and I don't have an answer for you right now. I'd need to go and check. The tiers that I'm aware of with managed disks are just the standard and the premium, and they've got different price points dependent on the size of the disk. I'd need to just confirm if the disk is just at rest, how it's charged. Sorry, I don't have an answer right now for you.
Encryption feature. I say that it's automatically encrypted.
In the data center, it's protected. However, there are two additional encryptions available. But I think they're also available for the regular storage disks as well. One's at I'm sorry, I can't remember the name of them off the top of my head, but one's at the infrastructure level and one's more like BitLocker, which is more for Windows type machines. But the encryption is available. So. That's right. Sorry, I can't answer it more fully there. Any other questions? Oh, okay. So moving on, some demos. So what do I need to do? Okay, so this will be a screen that you're very familiar with. Is that showing through, Canio?
Yeah.
Okay, great. I've pre-built some virtual machines. We've actually got 3 here at the moment. But what I'm going to do first of all is using the GUI, be very boring and step through building a virtual machine, just so I can highlight the options available, okay, surrounding managed disks. So let's add a disk as a virtual machine. No, I don't have any particular bias towards Ubuntu, other than a Windows VM for me takes about 15-20 minutes to provision, and a Linux one usually takes a few minutes, so it's a bit quicker. This is, well, I'm going to be really imaginative and call this VM04. You've got the disk type, so this is your first choice. You know, if you're going to go for what's effectively going to be the premium storage, it's going to be running on SSDs, if not hard drives. You've seen all this before, I imagine. I don't have an SSH key with me, so. Type good. Okay. Okay. Don't know what that
Check
means.
your location then.
There we go. Well done. I've got the vault. I've got the. There we go. Well spotted. That was a deliberate mistake, and I was just wanting to see who was paying attention.
We have a present.
What's that?
We have a present.
Yeah. There's a Canio's got a pen he's going to give away. Right. So let's put that back in SSD for the time being, and.
I'm going to zoom in just a bit because it's a bit.
Okay. Okay, so I'm just going to choose one of these. Doesn't really make too much of a difference at the moment. Okay, so this is the bit that I was really wanting to get to. Now, at the moment, we're not going to put this in an availability set, but the storage is what I want to talk about. Storage, you can now see that it's defaulted on yes for managed disks. So when you create a VM now, this is what Azure is pushing for. Have a managed disk. It is actually easier to use than building a storage account and then creating a container and then having having the VHDs in there. And as I mentioned before, there's a few other benefits to having managed disks. But the option's still there. You know, if you need to have geo-redundant storage, for example, you can create a storage account and set it up that way. It really depends on what you want to do. Unmanaged disks are not going to go away, not for a long time, I don't think. So I think that there's going to be the option, dependent on the scenario. You'll see that if we're not using managed disks, then it invites us to either create or use a storage account. And in case you're not aware of this, you need to make sure that the name of the storage account is unique within Azure, which can be a bit of a pain sometimes, but there you go. But if we go for managed disks, we don't have an option for storage account. But that being said, if you want to have diagnostics in your on your VM, you still need a storage account. You still need somewhere to put the diagnostic files, the outputs. So it's just something worth considering. You may want to have just a separate storage account for all of your VM's diagnostics. It just depends on how you want to do it. All the other stuff's pretty straightforward. Virtual network, subnet, public IP address, network security group. No extensions. Oh, this is off topic, but this is a really cool feature. Auto shutdown. In case you have not seen this, it's something that's been added recently by popular demand. Great for development situations. One thing that most developers, engineers are not really bothered about, but their managers certainly are cost. If you leave a VM running 24/7, it will be charged for. This little bit of automation, you can set a time and it can shut down in the evening. You know, you finish for the day. Let's just say you set it for 6, 7 o'clock every evening. So if you forget to turn it off, you're not going to have your manager shouting you at the end of the month saying, why is your subscription costing so much? So it's a nice little feature. Nothing to do with storage at all. And there's the diagnostics that I was saying. So if you want the storage account if you want to have diagnostics, you still need to have a storage account. That's really it. That's not that exciting at all. So I'll just move on to PowerShell. Is everybody in the room familiar with PowerShell to one level or another? No? Okay. PowerShell is a wonderful way to actually manage infrastructure within Windows systems as well as Azure systems. There is work to make it available for Linux as well through a desired state configuration. That's just a declarative version of PowerShell. I'll talk through the code that I've written, very brief explanations. If there's any questions, just ask, no problem at all. There's not a lot of it in this case. Okay. That's fine. Right, so just an FYI, I'm using the ISE, which is something that comes with Windows systems. It's a tool for writing PowerShell. It's got IntelliSense, so it will help you to write the code and give you suggestions. If you're just as a quick PowerShell primer, usually it's verb-noun. Get something. Set something, install something, and the first one I've got here is login Azure RM account. So I actually had the pleasure of meeting Jeffrey Snover, who invented PowerShell, and lovely guy, but he told me that he's very forgetful. So he wrote PowerShell so that you wouldn't have to remember anything. You could just type and it would do what he wanted it to do. So, and I like it that way because sometimes I'm forgetful. So, okay, so what we're going to do here is we're going to look at 2 VMs, and we're just going to convert them to managed disks. Pretty straightforward. I will quickly jump back to the portal so we can see a blank screen. Okay. Okay, thank you. So I'm going to virtual machines by resource group. Okay, actually, let's go to resource groups. Okay, so I've got 1, 2, 3 virtual machines. I've got 1 storage account, 1 availability set, and one VNet, and obviously network adapters for each VM. But there's no disks there, other than if we go into the storage count, and then we look in the blobs, and we've got some boot diagnostics, but in the container VHDs, we should have, there we go, 3 VHDs, one for each VM, okay? So this is now called unmanaged disks, and this is probably what you're used to, okay? Let's start with VM02. Now VM02 is just a standalone VM. It's not an availability set, so there's no link to other VMs for high availability. It's just standalone. We've got 6 lines of PowerShell to start with. The first 3 lines are just defining variables. Anything with $1 is a variable, just for convenience, really. There's just three commands here. One to stop the VM, and that's important. So if you're going to convert, you're going to have to stop the VM. The conversion's pretty quick. It's like maybe 3-4 minutes. So it's as long as you've got it set up so that you can handle that downtime, then a conversion's pretty straightforward. So stop dash Azure RM VM. Just defining the resource group, the name, and we're going to force it through. And I like to put verbose on the end because it just tells you stuff. Sometimes it tells you useful stuff, sometimes it doesn't, but I like to have it there. But the actual line of code that does the work is just convert to. It's pretty straightforward. You can see where Jeffrey Snover was going with that, you know. Convert to Azure RM VM managed disk, and just some of the details there. And then we just start it up again, which is line 22. That one there. So if I should be logged in already, so I will just run that. And we'll probably wait a minute or two for this to happen. It's very exciting as it happens. Yep.
That convert to command that you're running there is taking the VM as an argument.
Yes.
You're directing it as at a VM. Is it going to convert all of the VHDs that are attached to that VM to managed disks?
Yes.
Okay. And is there another set of arguments where you can point the convert to command at an individual VHD instead of a VM?
Yes. So you've got a VM and it's using an unmanaged disk, and you just want to convert that to using a managed disk. That's what that commandlet does. It just takes the VM, sees what VHDs it's got, and then converts them. And then that's it done. If there are separate commandlets, I don't have a note of them here at the moment, but there are separate commandlets that you can take a VHD and convert it. A good scenario for that would be, let's say you've prepared a VM on premises. Perhaps it's a generalized image, or perhaps it's specialized. Generalized being you can use it over and over again for different virtual machines. Specialized as in you just want to use it for one virtual machine. So you've got one on premises, you spend a lot of time on, you upload it to Azure as a VHD, it will go into a storage account, and then you can convert it to an actual managed disk. You could have that as an image and then use it multiple times if you wish, or just attach it to a VM. It's pretty straightforward. Another scenario is if you're migrating to another subscription. You can convert a VM first to use a managed disk and then move that over to another subscription. Or if you want to just rebuild the VM anyway, you could convert the VHD independently, copy that over, and then build a VM from that. It really depends on what you want to do. I suppose if you want to put a slightly different part of technology, if you have a VM that's independent and you want to add it to an availability set, you can't move it into an availability set or move it out of an availability set, you have to rebuild the VM. So that's another scenario that you could maybe use the convert at the same time. So you convert the VHD and then rebuild the VM. Does that make sense? Did I over answer? Sorry. While we were discussing that, it's actually done the job. So let's just switch back to a blank screen. There we go. Let's refresh this page to see what's happening. Okay, so what we've seen happen here is that VM02's OS disk is still there. Okay, it's not available. It's not attached to anything, whereas the other two are attached to VMs. So you don't lose what you've already got. You can then go and delete it. You know, I think we can go in here and then delete or download. Maybe you want to download and archive it. I don't know, something along those lines. But if we go back, and do a refresh, we now have a managed disk, and it should be attached. It is attached, and the owner of the VM is VM02. So we can start this VM up, and there's nothing else you need to do. That's it. So as far as the VM is concerned, it's just been powered down, and then it'll get powered back up again. So that's how to do it with a standalone VM. There's a slight change if you want to do it with VMs in an availability group, which is probably more likely the scenario, or it should be more likely a scenario. You should all be putting your VMs in availability groups. Okay. So let's jump back to PowerShell. What I'm doing here is I'm actually getting the existing availability set. Again, very straightforward, get dash Azure RM availability set. Okay, and just specifying a couple of parameters. We need to make a slight change to the platform domain count. The standard is 3, but that's not supported with managed disks, so we just have to adjust that down to 2, and then update the availability set with what the change that we've just made, and make sure that it knows it's going to deal with managed disks now. So that's an important tag to put on there. So we're going to do, just a moment. Okay. We'll run that. Should make the change. Should be quite quick. Okay, so what's worth checking here is now in the state of the property of managed. True. And it had to update the default domain count in order for that to function properly. This is just a for each statement. This is we'll basically see how many virtual machines are in this availability set, get that information, and then run through each virtual machine and basically do the same commands that we did a moment ago. So rather than doing each one individually, this does it all for you. And it's just an extra line of code. Oops. If I run that, I get an error because I missed the closing bracket at the bottom. Again, one of the things I like about PowerShell, more often than not, it tells you what you've done wrong. It's not failed, it's just the user has failed, but at least it tells you where you have. Let's try again. Very exciting. Any questions while we're waiting for that to run through?
Yeah, something basically like from inside the VM, Is there any advantage in the performance or any other benefits?
From what I've read, the performance is better, but I don't have any numbers to back that up. Really, it's from what I've seen of it already, it's just more of a managerial or administration benefit. You don't have to deal with storage accounts. You don't have to think about any of the limitations in storage accounts in terms of the bandwidth of those or the maximum number of disks. Although disk size is an important point, actually, they're now in blocks. I think it's 32, 64, 128, and they're charged for those sizes. Doesn't mean you can't have 129 gigabyte drive. You can, but you'll be charged the next one up. Okay. I think they're trying to simplify the cost for these disks. Yeah, in terms of, I don't think there's any specific benefit for anything from within the VM, but certainly from a managerial or administrative point of view of Azure, you've got a lot more control of the resource now because it's a top level resource, and you don't have to worry about storage accounts anymore for the disk.
One disadvantage of VHD is like you can reduce the size of the disk easily. You know, the defect or something, so if you have all those problems about.
You're still going to have that issue in reducing the size. You can increase the size easily. That's more of a limitation of the technology. You're absolutely right. If you want to reduce, say, like a Windows VM VHD, you need to make sure all the data is squashed up and all together. You know, Windows sometimes has this habit of like taking a tiny bit of data and throwing it at the end of the drive, and then you have to defrag, and sometimes the defrag doesn't work and all of that sort of stuff. But yeah, you have to reduce it within Windows first, and then reduce the VHD itself. That's certainly the case for Hyper-V, and it's the same technology, so you still have the same problems. And while we've been chatting, it looks like the availability set VMs have all been converted. There's only one VM in this availability set, so again, not that exciting, but we're going to get a blank screen again. There we go. So previously we had VM 02 OS disk there, and if I give that a refresh, we've got VM 01, okay? But I'll reiterate though, I didn't specify the VM this time. I just specified the availability set. So basically the PowerShell went in here, had a look around, oh, what's in this availability set? Oh, there's one VM, and then it did the conversion for that one VM. If there was 20 in there, then it would have done all 20. Same amount of effort. That's one of the reasons I like PowerShell. I'm lazy, so I get PowerShell to do all the work for me. Anyway, that's really it, unless there are any questions.
One question. What are the differences between Azure PowerShell and Azure CLI?
Azure CLI you can use on a Mac, or you can use from Linux, or you can use it on a Windows machine as well. They both use the REST API, is that right, Kenny?
Yeah. Everything is ARM API.
Yeah.
But
PowerShell is kind of a Windows-only thing at the moment. They're trying to spread it out a bit, but Azure CLI you can use from different systems.
Okay.
The syntax is a bit different, but it's just as powerful.
And also there's like a competitive advantage because sometimes the new commands are coming first in PowerShell, sometimes in CLI. And now you can run the CLI in the context of the Azure portal. So if you might click this thing on the top Next to the bell.
Next to the bell.
Yeah. Yeah.
Yes.
This is the CLI. Basically, you need to set up a storage account, but you can upload your SSH keys. So we allow you to run it here. And there is a big push to make it more friendly. I think this experience is a little bit similar to what we've seen in other cloud providers. So you don't need to install it locally on your system. It's already in the portal.
I've actually thanks for bringing this up, Kenny, because I actually was playing with this last week on my tablet. I've got an Android tablet, and the Azure Android app is really good for just checking stuff. You know, you can see what you've got. Oh, there's a VM running. Oh, I need to restart that VM, or you want to see what resources. For building, not so great, but just for having a look-see and doing a little kind of basic stuff, it's great. It's also got the CLI in there as well. So it felt really weird going in there and had a command line, command prompt on my tablet, you know, sitting on the train. I was like, I can do what I want here. I can build an infrastructure with this command line. But yeah.
And the iPhone app also has the same command.
Yeah.
Yes. So
very cool.
Well, I mean, I think a few years ago that would be unheard of in Microsoft, but their shift to trying to be a bit more open with all the different platforms that was available is very reassuring. So, what was it I saw recently? It's been around for a while. It's like Microsoft loves Linux. I mean, that's maybe a bit much, but you know, no, okay. But as you can see, we've now got a prompt up there. So
yeah.
These managed disks, do you think that they will maybe be available for other services in the future?
That's a good question. I don't know. I don't have any insider knowledge. Unfortunately, I don't work for Microsoft, although there's someone across from me that works for Microsoft.
What would be the interesting use case for you? Where do you want to see them?
Well, I mean, when you deploy like a function, you have to have a storage account, and then automatic folders are created.
Yeah.
Same with web jobs. There's a lot of just, I guess, like automated stuff that's done for you, but it's all.
But here we need to point out that these blobs that we see, these are actually page blobs. It's usually used only for virtual machines, hard disks, and the blobs that we're using usually in functions are like how is it called? Not page blob, object blob, I think.
Right.
The other type of blobs. So I think it's a very interesting question. You know, probably we should escalate it and ask somebody about that. So basically, you don't want. Actually, I had the same question. And so far, I think they were thinking mainly for the virtual machine scenario, but probably in the future, maybe we can see something. But I haven't seen anything. I think the main constraint is like especially when you start building big applications that we have a lot of data, you don't want to start thinking about sharding the storage accounts. You just want to know that you have as much space as you want.
Right.
Yeah, I think this is a great question. Let me try to find it if I can.
I think Microsoft, in the past, I've worked with some of the Microsoft development teams when they're looking at the next iteration of Windows Server, for example. They're always keen to hear about what scenarios are of interest to their customers. So I don't know if you guys can maybe follow up. We can follow up with Kanye. Maybe you can speak to the appropriate people and see if it's something they can consider.
Okay, have you heard something about that, like managed disks for all type of blobs? Now, Mike showed like a managed disk for page blobs, but have you heard about managed disks for like object blobs or something?
I think I do.
Okay, we'll check.
I've just this is not very clear on our screen, but these are just some of the commands for the Azure CLI, because that's effectively what you're using in this command prompt here.
Yeah.
And these are the same commands that you would use if you installed Azure CLI on like a Linux machine or on a Macintosh. Like that. And don't forget, you've also got ARM templates. You should all be studying ARM templates. And anyone not know what I'm talking about? No. ARM templates are pretty fantastic. You just define what you want, and then it goes and does it for you. There's no, with PowerShell, you write a line of code, do this, then you have to do this, and then you have to do this, and then you have to define as it goes. With the template, you just say, well, I want this resource, and I want that resource, and this other resource, and they're linked in this way, and then it goes and does it for you.
Is there any IntelliSense for ARM?
So when I first looked at ARM templates, I was terrified. I did a short course online how to use ARM templates, and I did it in a text editor because I couldn't find anything that had IntelliSense. And I kept making mistakes, and none of my templates worked. Basically, my syntax was incorrect. Visual Studio is the way to go. Now, Visual Studio Community is a free one, which has IntelliSense. You can add the Azure components to that.
Visual Studio Code. Is it?
Well, that was the other one I was going to mention.
Yeah.
So Visual Studio Community is like just a cut down version of Visual Studio. You can use it for all sorts of things, including ARM templates, which are in JSON. It will give you a nice graphical depiction on the left-hand side of what the resources you're creating, and you can get and you can get templates to actually create more. Now, not everything is in there. It's not super up to date, but a lot of the different resources are in there. On that note, though, you can in the portal do the same. So if you go into new and I go template, I get no results. Okay, try again. Can you help me out here? Template deployments. What's that called now?
I don't know.
Templates? No. I thought it was template. It's just not searching right. Okay. So if I know this is slightly off topic, but you can start using ARM templates straight away if you use what's it called? It's a Quick Start, Azure Quick Start. Yeah. Directly from the portal, you can access a lot of the Quick Start stuff. It's all held on GitHub as well. Down here at the bottom, you can actually start. I don't know. One I like is OpenVPN.
But also they have a button thingy. You click.
Yes. So if you're using, if you go directly onto the Quick Start Azure Quick Start web page, and you find a template of interest to you, because usually have what it's called, a nice description. It's community driven. There's a button there, just like click, and it will send you to the portal. Or it gives you examples of PowerShell or Azure CLI of how to deploy that template. Or you can do it in here. So if I select that template, oh no, hang on, let's edit the template. You get a nice, on the left-hand side, you get a nice list of your resources and your variables and your parameters. And there is a level of IntelliSense in here that it's basically at least coloring things for you and matching up the brackets. And this is what I didn't have initially, and was why none of my initial templates worked. There's just error after error. But with something like directly in the portal, looking at the template, or using Visual Studio Community, which is the free version. If you have the paid version, that's fine as well, that'll work. You just have to add the Azure components. There is Canio mentioned there's another Visual Studio, it's called Visual Studio Code. It's like basically just bare bones for coding. And you can add some Azure plugins to that. It doesn't give you the graphical thing that we've got on the left, but it does give you the IntelliSense and helps you with your syntax. Any other questions? Okay. Good question. Yes.
Can I use nested template in this Azure template deployment?
Yes, you can refer to a separate parameters file. So if you've got, you can split some of the components out. You can also, if you want, let me clarify. The template will build infrastructure. Okay, it will build all the bits for you. If you're, and this is not just VMs. This, this is like web apps, and I think you can do functions as well. Can you? Is that right?
Yes.
Yeah, it's all sorts of Azure goodness it can do. But if you're building a VM and you want to do some changes within the VM, then you absolutely need to refer to something outside of the template. And I think this example does have that. So, okay, so what this down the bottom, what this is using is an Azure extension for running a script within the VM. This is a template I've used a couple of times. It will allow you to build a personal VPN server. Let's just say you want to watch Netflix in the States. You could build your own VM in Azure and VPN to it, for example. I know you shouldn't do that. Probably shouldn't be saying that, but you can do it. Not that I'm suggesting you should. The ARM template will build the VM. It will get the image of Ubuntu, the latest version. Let you put in your SSH keys or passwords or whatever. It will set up the network. It will do all that sort of stuff, but it won't do any configuration in the OS. So this extension, this custom script extension, is actually pointing to somewhere on GitHub, and it's an SH. It's a shush script to do the configuration for you. So yes, you can. Oh, you're welcome. Good question. Anything else? I can hand the baton over then.
Thank you very much.
No, you're very welcome. Thank you for listening. Hope my accent wasn't too strong.
I think it was great. So now I want to introduce Naoki. Maybe you know him. He's very famous. He's one of the data evangelists in Japan. Yeah. Covering so many different areas in Azure and Microsoft in general. I have the privilege with him like a few years ago, and today he will be talking about deep learning, which is super hot topic. It's very impressive request for learning deep learning. Now with Naoki to take it from here. Just start broadcasting. So yeah, you're sharing. Should come. Yes. Yep. And just you need to select key and which screen do you want to present. No. Okay. It's okay. Just 1 second. Good.
Okay. So let's get started. My name is Naoki Sato. I worked for Microsoft since 2010, so it's almost 7 years. And and since 2010, I worked as an Azure evangelist. So, and at that time, Azure was terrible, but now Azure is getting better and better. So I'm really enjoying.
Oh, it's great.
Yes. So, and today I talk about deep learning and Microsoft different toolkit called CNTK, or officially cognitive toolkit. And before that, I show my blog and Twitter. So this is my blog. Sorry for in English. Japanese only. But I share my recent slides and some updates of Azure and other stuff. For example, sometimes I translate the official blog, like, for example, this is CNTK 2.1 release announcement blog. And, and also regarding Azure blog, most of the important posts is translated by Microsoft Japan, but sometimes some important post is dropped, so I translate these posts in my blog as well. So please check my blog and Twitter as well. So, okay, so today I prepared two slides. One is a quick overview of CNTK, and other is a quick introduction of deep learning. So, which one do you want here?
Which one?
CNTK or overview?
Deep learning. Deep learning.
Okay. So, okay. So, so I talk about the quick introduction of deep learning, and then I show some deep learning training on CNTK on Azure or open host as well. So, okay. So this slide is taken from the ETX online training by Microsoft. So if you'd like to learn more about CNTK and deep learning, you can run by yourself. So, so the online training is delivered by the data science PhD, but I'm not a professional data scientist, so I'm running the deep learning right now. So, so at first, I'd like to talk about machine learning before deep learning. So, do you have any experience of traditional machine learning before deep learning? For example, Azure machine learning or any other machine learning experience? Okay. So I will talk about quickly about machine learning. Machine learning is the goal of machine learning is to predict something using the existing data. And there's several variations of machine learning. One is supervised learning. So in this case, this is existing data, training data. And in this case, we know the answer of the prediction, in this case, blue or red. So our goal is to create a kind of predictor or classifier to the new data and to predict for blue or red. So this is a supervised learning. And other variation, unsupervised learning. So in this case, there's no correct answer in hand. So we just cluster or categorize these data into several groups. This is unsupervised learning. So, I'm sorry, my bad English. No. So in supervised machine learning, there are two variations: classification and regression. Classification is to classify the data into two or more categories. Most simple case is email spam detection. So in this case, we have a bunch of existing email and which emails are spam and which email is not spam. So with this knowledge, we would create a classifier, spam classifier. And then after that, when you email pen, we can predict this is a spam. So this is the classification. So in this case, the two class classification, but in some case, 3 or 4 more classification is available. And regression is a different type. In regression, you will predict the number, not classification. So in this case, for example, if you have a information house, for example, how large the house is, or who owns the house, or something like that, and the goal is to predict the price of each house. And this is supervised learning, so you have a bunch of information about many houses and with price. And after you train predictor with this data, you can predict the house price with house information. And there are many real-world applications of machine learning, like image processing, like autonomous driving, or disease detection, or natural language processing, like machine translation, like Microsoft Translator, or document comprehension. And speech recognition is a hot area as well. So, as you might know, Microsoft Cognitive Services provide a speech-to-text or text-to-speech API. And in these scenarios, machine learning, or most of these implemented by deep learning. And what's deep learning? Deep learning is a subset of machine learning. And neural network or neural net is one approach of traditional machine learning. And in these 5 years, new approach, which is called deep neural network, is getting popular. And this deep neural network is recently called deep learning as well. So basically, deep neural network is a neural network with many layers. I'll talk about layers after later. So anyway, deep neural network is a very complex neural network model, and recent advance of public cloud and GPU enable this kind of deep neural network. So let's go back to simple machine learning sample. And in this case, this is a solar panel scenario. So we have data of average day temperature, X, and the solar panel output, Y. And in this diagram, there are several readings of existing data. And the goal is to draw a line which is best fit to this existing data. So in this simple linear example, the goal is to know the best number for M and B. And M is called slope, and B is called intercept. And this is a super simple machine learning model. Yeah. So with this model, if you have new X data, you get the prediction of Y value. Easy enough. So there's a typical workflow of machine learning. First is training. And training data, like this graph reading. So, so the value we'd like to predict is called label. In this case, Y is label, and the other various data is called feature. So in this case, this is a supervised learning. So you have a bunch of data which include features, and a label. So this is a training data here. And using this training data, you will train runner and search for the best model parameter. And after that, you will use something called loss function, which is a kind of metrics, the difference between the predicted value and actual value. So if loss function value is smaller, which is better. And if training is not enough, train again and again. So this is the training phase or workflow. And after that, typically we will use another data set called validation data and apply the final train the model and check the loss function value. And if the loss function value is small enough, we think the model is good and the model is finalized. So in many cases, the loss function for training data is very good, but the loss function value for validation data is not there, not so. This is called overfitting. So we need to avoid overfitting. So, and finally, we have a finalized model. We can apply test data to the model and we can evaluate the quality of this model. So, and this is a typical workflow of machine learning and deep learning as well. Okay, so let's move on to the most simple deep learning model called logistic regression. Anyone has any questions? So in this case, we will use the sample data set called MNIST. MNIST is a kind of hello world in deep learning. So every deep learning framework use MNIST as a first tutor. So MNIST dataset is 100 digits from 0 to 9. So there are 10 categories. And we have 60,000 training images and 1,000 test images as well. And each 100 digit is 28 by 28 pixels, very small. So, and so this image is features in this case, and the label is one of the 10 digits. So, and in this logistic regression sample, First, we will transform the input image to the 784 pixel data, and each data have a value of 0 to 255 value, which shows the density of the pixel. And the goal is to create a good model to predict the best number for this pixel. So in this case, the output is 10 numbers, something like this, and the largest number is the best case of this image. So in this case, 3 is predicted, and this is correct. So we try to create the for the each of 10 numbers. We will have a how to say that 784 input data to the one output data. So this calculation is described as kind of a matrix calculation. So in this case, Z is WX plus B. And W is weight, and B is called bias. So for each of 10 numbers, we have some calculation something like this, and we can merge this 10 calculation into the single matrix calculation. And our goal is to guess the best number of weights and bias. And typically, in deep learning, something called activation function is used. In this case, sigmoid function, which is in the form like this.
What is the role of the activation function?
So in this case, if the input number is unlimited, but output is from 0 to 1. So this is some kind of normalization.
I see.
So in this case, and other activation function is called softmax, which is used for classification scenario like this. This is a classification into 10 category. So in this case, we will normalize the probability of these numbers into the so that the sum of these 10 probability is will be 1. So this is another type of normalization. Those functions. This is a little bit difficult, but in this case, something called cross entropy error is used as a loss function like this. And our goal is to minimize the value of those functions.
So basically, we'll try different predefined functions and see which one works best for
for us.
Yes. So we change the weight and the bias to minimize the loss function, which is the best fit to the label. To the so workflow is same as before. So, it's a complex step, but this is a feature, 784 pixel data, and this is something called one-hot encoded label. So, which means if, for example, this array shows 0, 1, the 3 is correct. So we have 10 arrays for each of 10 labels. And we will do some mathematical calculation and calculate the loss function and search for the best weight and bias. And this is a function in CNTK. So CNTK provides a very high level function and methods for deep learning models. So it's very easy to describe this kind of deep learning model in a Python code.
How much we should understand, for example, let's say we use the underlying math.
To be honest, these are implementation details. Many of users don't understand that.
Okay.
Yeah, detail.
So is there something, I know for machine learning there is a cheat sheet, right?
Yeah.
That tells you, okay, in this case, maybe this algorithm is well for you, good for you. In this case, this. Can we have the same approach in deep learning with CNTK? In this case, I can use cross entropy function. In R1, I can use like a softmax.
I think most of users have difficulties understanding these details. And in CNTK, there's many existing samples for major deep learning implementation, like AlexNet, GoogleNet, ResNet, or something like that. So you can use the sample as a starting point and then tweak some options to best fit your use case. So,
can I just ask? So yeah, the implementation of this, once you've got an idea of the functions that you want to use, then it's pretty easy to start using that within Azure. You'd implement it through the portal, or
actually, CNTK is just a framework, and you can use CNTK in Python or BrainScript, which is a proprietary CNTK scripting language. So you can learn anywhere,
right,
in Azure or in localhost or AWS. But we recommend Azure, of course. So, and so how to search the best weight and bias? This is a mathematical detail, but the approach, which is called gradient descent, is used in this case. So in this case, you start somewhere in this and go downwhere, and the bottom is best. Yeah. So, and there's several variations. And same validation and test workflow. And if you have final validation model, you can pass the image pixel data to the model, and you can get the answer. So in CNTK Python code, this is you can use eval functions to evaluate or predict the label. And the result is the array something like this. So you can pick up the largest number and understand the predicted value. In this case, which is just this one. So in this case, 9 is predicted. So I'll show you how this works in CNTK. So so as I said, CNTK is just a software implementation, and you can run CNTK in various environments like Linux, Windows, Docker configuration, and you can install Python only installation using pip or pip command, or you can install the Python and other traditional brain script stuff as a script-based or manual installation. So if you have interest in CNTK, please take a look at this document. You can access the document from cntk.ai. It's the best URL I know. And it's redirected to the official CNTK website. And document here, and tutorial, and various existing model sample as well. And GitHub source code here. I think there's several CNTK sample in protein integers gallery, but just a sample. So, and if you would like to use CNTK in Azure environment, you can easily install your Windows, install CNTK to your Windows Linux VM, of course, and also you can use data science VM, which is the VM image Microsoft provides, and it includes various data science related software. So, so we provide several data science virtual machine images like this, and basically there's an image for Windows and Linux. It's to Windows and simple and boots. These two are Linux based, and the deep learning related software is installed only in Ubuntu image. So please use this image. And in this image, very most of the popular open source software is installed like this. Python, Jupyter, and other stuff, and VS Code, and so on. And deep learning framework like CNTK, TensorFlow are installed as well. And good thing is the NVIDIA driver is installed as well. So if you create this image with NC series VM, the complex NVIDIA driver installation is already done. So you can just use it.
What's the name of that series of
NC.
NC?
Yeah.
Is that available globally or just in certain regions?
It's available only in United States and some Europe.
Okay, so and that's just special hardware that has the NVIDIA
Yes.
processors.
Yes.
Okay.
So, so regarding regions, you can check the available region in change to English. Regions page. Compute. Search for NC here. And it's available several US regions and that. There are so many regions recently. Now we have 42 regions worldwide. Yeah. So and US government region as well, and North Europe and West.
Japan?
Not yet, but the future version of GPU instance will be available later this year. It's already announced, so please be patient. So let's go back to the Azure portal. As I said, CNTK is installed in this virtual machine image, but the version is a little bit older, so I recommend to update the latest version of CNTK. The instruction is on the document page. Right. And I also installed CNTK in my local Windows machine, and it's running here. So, and let's run the. Oops. Let's run the web interface called Jupyter Notebook. Let's run. So it's running here locally. So Jupyter is an interactive web interface for Python or and other data science related technology like R. So, and CNTK provides a bunch of sample and tutorial for Jupyter Notebook. So you can run Jupyter Notebook. You can run tutorial on Jupyter Notebook very easy. And if you create a data science virtual machine, you can access to the same interface through the port 80 or something. So that remote Azure VM. And other way to access to this Jupyter Notebook is to use Azure Notebook service. Does anyone know this service? It's a very minor service, and we don't promote this service. But this is a free service too, and you can run any Jupyter Notebook online for free.
Nice.
Yeah, and so please access notebooks.azure.com and log in your Microsoft account or organizational account. And we provide many sample notebooks like this, introduction to Python, R, or CNTK sample here. So if you would like to access CNTK sample here, just click the CNTK introduction. And some similar sample is available here. Click Chrome. and login account. And name your library. I think I already have 6. And if you check the public library, you expose your library to the world. So I recommend uncheck this option. And click Chrome. You can access the notebook here. And user interface is almost same for the local store version. So this is local, and this is Azure Notebook version. Almost same. And so let's show some sample here. So regarding MNIST, there are 4 sample tutor here. And first one is to download the MNIST data from internet. So this is must. And you can choose one of or all of these 3 variations. I only show the first logistic regression scenario until now. So, and this is a notebook interface, and you can select the code block and run this block called cell, or quickly you can run all cells in one action. So this tutorial is download the MNIST training data and test data from internet and unzip the data to the local text file. So, and I'll show the downloaded file. I lost the directory. tutorial. I forget the directory. Okay, I open the downloaded data from Westcode. So please, here it is. So this is downloaded training data, and this is a label. So, for example, this is row, label is so 4, and feature, this is 784 pixel, and we include the pixel data like this. So this is a value from 0 to 255 values for each pixel. This is a training data, and test data is similar to this.
So each line represents just one
One
bit
number.
of test, one bit of test data,
Yes. One handwritten image
one image, but
and
one, yeah.
label. Feature label.
Thanks. Oh, that's Visual Studio Code you're using, isn't it?
Yeah.
Yes.
Yeah.
I love
That's
it.
one of the tools
Yeah.
I was mentioning earlier.
Okay, and then let's move on the logistic regression sample. and try to run O, and so just some quick overview of this scenario I showed, similar to I showed before, and actual model is created.
So after you run the whole Jupyter notebook here, you have the model already done, right?
Yes. So model is defined here. It's super simple, just 4 lines. And training, it's down right here. Cruise entropy is defined. And some configuration of training here. So there are several options to the training, like running rate or several other stuff. And here's the actual training is executed here. And we take the, in this case, 64 data and do some training, something called mini batch, and we keep executing mini batch until the all training data is executed. And here's the process of mini batch, and as you can see, the loss function value is decreased. So this is improving over time. And error rate is improving as well. There's some variations exist. But the overall, the accuracy of model is improving over time. And you can easily visualize this kind of data in Jupyter. And do some testing here. And here we can take several test data and predict the value. And we can see there's some incorrect prediction here, but overall the prediction is correct. And in this case, the image level is 8, but actual number is 9. So this is incorrect, but you can pass any image data and predict the value.
So we need to continue trying.
Yes, but logistic regression is a kind of primitive one, so you can use another model like convolution network to improve the quality.
Nice.
Yeah. So this is I show the quick overview of training and test model. So as you can see, if you know Python, it's very easy to understand as a Python code, but if you would like to know understand the detail of different model, it's very difficult, I think. Anyway. And I think it time.
Finish.
Yeah. So this is the most simple one, but there are more contents like trigger perceptron or CNN or convolutional neural network. And in image recognition, CNN is very popular. For example, AlexNet is a start of deep learning movement. In 2012, do you know ImageNet? ImageNet is a popular academic image repository, and ImageNet hosts large-scale visual recognition competition every year. So many researching try to improve image recognition quality, and every year submits the best result. And in 2002, before 2012, no deep learning approach is submitted to this competition, and this is the first deep learning approach, and it improves the accuracy almost 10%, and many machine learning people surprised. And after that, in 2014, Google was a winner with GoogleNet model. And also VGGNet is number 2 in 2014. This is also very popular model. And in 2015, right to one. And this is the model is called ResNet, or residential networking. And the layer is 152. So it's very, very deep layer model. So in CNTK, we have a sample implementation of AlexNet and GoogleNet, VGGNet, and ResNet as well. So you can try this model, just executes a sample.
I'm trying to understand.
Yes, but you need to
PhD.
And a bunch of GPU machine to complete that.
That you can
small
find in
sample.
Azure.
Yeah, and pay for Azure.
What do you think would be useful applications?
So most
Obviously, there was image recognition is the competition that we do.
Yeah.
And the OCR is a training one, but still very useful. What do you see as like different things that this could be used for in the future?
So typical use case of deep learning is image processing, recognition, and speech text processing. And CNN is for best fit for image. And another model called RNN, recursive neural network, and LTSM, long-term short memory, is for time series processing like speech recognition or translation. And for the scenario, maybe you need to researcher to develop the new model or to your scenario.
But already we have like a good scenario. For example, with a Lewis, like for bot framework development, you see all these like approaches are sitting in front, like between the computer and the external environment. So they allow us to absorb and to understand what is the external environment. After that comes our computer engine that actually takes these findings and does something with this data that's coming. So if you imagine like a bot, you're talking to the bot and it naturally understands what you're talking about. And then inside of the code of our bot, we're doing something with the input that we're taking. So all these things is kind of like a gateway of understanding the environment. And after that, you need to integrate it.
Yes.
Microsoft has this thing called Cortana Intelligence Gallery.
Yes, I'll show you.
It actually pose business problem,
Yes.
Yeah. Would I-
So, so you can find various data science related sample tutorial implementation example for Azure Machine Learning, CNTK, or any other data science technologies.
So when I put this in, I don't have any comment.
Here.
There is a studio.
Machine learning studio,
Ah,
or it's Cortana studio?
I'm not sure. What is it?
Machine learning.
so this is a Azure Machine Learning studio, and you can. This is not related to deep learning, and this is for traditional machine learning before deep learning. But you can create various useful scenario using this tool, web-based tool, and
But we cannot build deep learning.
yes,
It's interesting that it's using the old interface.
Yeah.
yeah,
The old
like all photo. Yes, definitely. Let's show you some. The workflow is similar to the workflow I showed before. So in this case, we have some training data here and split data to the training data and test data.
But it's not so deep, right?
Yes, shallow.
It's very shallow.
Yeah.
So, some of the machine learning is creating algorithms from data sets to get like an approximation of what the data is. Whereas deep learning is multiple layers.
Yes.
I really like it. I watched like one video talk about that, and they said that it's actually imitating how our brains are structured, right? Like you have like a different pieces of information, different neurons, and when they're connected, everything makes sense, and you can interpret the information in a different way. That's why it's so layered. And I think this is so cool because we're imitating how we try to think.
That's really hard in reality.
Yes.
Because I have 1 year old, 1.5 years old. So she started to learn how to calm down like
Yes.
leg first.
Yes.
I didn't teach her.
Yes.
I think she learned because she fell down 3 times.
Yeah.
Hit down.
Exactly.
But it's just 3 times.
Yeah.
And I did not teach her how to fall down.
Exactly.
But she somehow figured it out. Machine is just far away. Because in order to train that, I need to give like at least, I don't know, like thousands of training sets. Right? If I don't do that, it's not going to work properly. But human doesn't.
But with the language, it's a little bit better. For example, if you use Louis, you need just to input like several patterns. And after a 5th, 10th pattern, if they're consistent, it will start to label very accurately. I think with images with complex movements like a crawling, definitely complicated. But still, the robots are challenging to keep balance, right? So I think this is complicated. With small stuff like close images and like close text, I think it's getting good.
So you mentioned about all this AlexNet, Google Net. How do you know what is the best? Does it have like interface that can be compared? Like I say I have something I want to predict who's coming to this state, right? How many people? Right? Then it would just run 5 algorithms and just compare them. Or within the same algorithm, giving 5 results, each with different parameters. So I must be adjusting some parameters. Right? It's not like a magic box.
Yeah, actually, each model is implemented based on the research paper from each team. So if you have deep skill, you can understand the model architecture and every option you can tweak. But I think most people cannot understand which is best for your scenario. So maybe you can.
So that means it's not ready for general.
In my opinion, what should happen is you should try it with your data and see like what are the results. And then you should try to improve your data if the problem is in the data. If not, then you should switch the model to something else. I think most of the data science people, they're really crunching the data, they're cleaning the data,
Yes.
changing it. This is like somebody said like 90% of the time. You're just like switching the form of the data, deciding what to get.
You're reducing the number of features.
Yeah.
Yes.
And after that, when you know what you want to achieve, when your data is good, I think it's getting obvious because you don't have unlimited number of models, right? And most of the time, you're not coming up with something super unique. That's why I ask you know, okay, but in the machine learning space, at least in Azure, you have this cheat sheet, which is like a kind of like a, is your data like this, is your scenario like this, then go with this thing. There you go. I think probably in deep learning space, something similar will come eventually. But until then, let's remember the maths universe.
Why was the Microsoft Machine Learning Studio, why does it not support CNTK or Jupyter?
Jupyter is supported. You can from here. Notebook is already integrated. But Azure Machine Learning does not support GPU yet, so it's very difficult to deep learning stuff effectively. So for now, we recommend to use GPU instance NC series virtual machine to run deep learning workload.
CNTK is a set of deep learning language or is it not?
It's a deep learning framework, so CNTK itself does not provide any implementation, but we have many sample for famous deep learning model. Where is that? Yeah. So this is a CNTK web page, and you can access the model gallery here. There are many sample like AlexNet or ResNet or something like that.
Like, how do you differentiate between TensorFlow? Is it similar to TensorFlow?
Yeah, similar to TensorFlow in the same market.
Okay.
So TensorFlow, Cafe, MXNet, China, this is in the same market. We are competing. Yeah.
And I think the topic is very deep, and I think it's very difficult to be covered in 1 hour. But we definitely will continue to build on top of the foundation that Naoki now set. There is huge interest about that. Obviously, there is a lot of difficulties related mainly with mathematics that people need to understand. But I think Microsoft, Google, other companies really try to abstract that to make it more accessible to people.
Yeah.
So I'm really optimistic that we'll have like a more and more powerful frameworks that allow us to integrate intelligence in our application. So I want to thank you today. I think it was a great start, and let's build more and understand more.
Sorry about the presentation.
No, it was very good. It was very good. I think most of us, we didn't have the chance to see everybody learn something.
Yes.
Thank you.
Thanks.
Thank you very much. Thank you. And I suggest let's go home.
Tired.
Can you stop sharing? Thank you very much for coming. If somebody didn't